2. Request number 2. All right, the first section is just one of these deals. How many triangles are possible? So remember, what are our possible answers? How many triangles are possible? What are my possible answers? 0, 1, or 2. So, all right, remember when you label your triangles, because you got to draw your own. Remember, when you label it, this side, it doesn't matter where you put angle C, but wherever you put it, the side across from it is side C. So if you put the 18 right there, then you're going to put the 4 over here, and then the 3 goes across from each. All right, so here we go. What do I do to get started on this? What do I need to do? Law of sines. So sine 18 over 4 equals sine h over 3. All right, so I can find sine h easily enough. And once I get that decimal, I can find angle h, right? Which is the key. That's what I need, angle h. So how do I get, once I type this in, and everybody should be typing it in with me, so that tomorrow there's none of this, my calculator's not working. Well, it's because you don't know how to work it. Practice. Once you get this decimal, how do we actually get the angle? Because that's what we need. Second sign that decimal that we get. And I got 13.4. Now, remember, you immediately step over to the side and say, okay, there might be a second angle H. That's my phone exploding because my siblings, God bless them, get in these things where they just send the most ridiculous stuff. And my little sister, my youngest sister will send something, and then the youngest brother will send something, and then my mom gets in on it. It's ridiculous. I mean, they're like 50 years old. Okay. If there is a second angle H, how do I find it? 180 minus the first one. So that would be 166.6. If there is a second angle, its measure would have to be 180 minus the first one. All right, so then you stand back and say, all right, would that be okay? Would it be okay? No, it wouldn't, because that's more than 180. So remember, it's if there is a second answer. There isn't a second answer. It doesn't work. So therefore, how many triangles are possible? 1. That's all there is to it. And we move on to the next problem. All right, so the next problem . Wait, this is a different situation. Would this be a law of sines problem?
No.
But what's different about it?
You can already find the other angle.
I can already find the other angle. Is there going to be any ambiguity?
No.
Is there going to be any chance of any angle being anything other than what it is right there?
No.
No, one triangle. One triangle. Remember, what is the only time I have to worry about all this stuff? When did my little antenna go up? When I have that right there, right? I will not have that in this problem. There is one triangle possible. You can find all the angles right off the bat. There's no confusion about the angles. That's the issue over here. We don't know what that angle is. It could be 2 different things. Here, there's no confusion. You know exactly what all 3 angles are. One triangle. I don't know, that was easy. All right, this one could have a little confusion, right? So we need to figure it out, which we can. So law signs would say what? Sine 73 over 16 equals sine h over 17. So find sine h. Everybody's typing it in, getting an angle h. And once you get your decimal here, then you second sign it, and whoops, what happens for angle H? You got an error message, which means how many triangles are possible? None. You don't have any with that guy because the sign didn't work out. The S-I-N-E just did not work out. Alright, so that is that one. Alright, so here we go. My setup here is identical, so we'll set it up just like we have been. Sine 73 over 15 equals sine h over 14. Did this triangle work out okay? Did you get an angle? 63.2. Okay, so the minute we get an angle, remember we step over to the side and say, okay, could there be a second one? Could there be a different angle H? Well, yes, maybe. And if there is, how big is it? 180 minus this one, right? So 116.8. If there is a second answer, it will always be 180 minus the first one. Is that okay? Can you have a triangle with that? Nope. So this is another case where that second possibility isn't possible. So there is only one triangle. All right, two more. Here we go. H was 4 and S was 5. Wait a minute. That would be a law of cosines problem. Wait a minute. Do I have to worry about stuff with the law of cosines? Do I have to worry about having second answers and all that stuff? No. How many triangles are possible? One. Just the one you got there. You don't need to work it out. Kids, remember, you have potential issues when you have this set up right here. If you don't have that set up, you don't have potential issues. All right, one more. So here we go. Sine 50 over 12 equals sine h over 13. This one could have a potential second answer, right? Look at the setup. See how it is? That means we have a potential second answer. If we even have a first answer, that's what we gotta check first. Do we even get an angle here? Or is this another no solution? All right, so what'd you get for your angle? 56.1. Now, what does that mean? Okay, there's a box right in here by the book. What does that mean? I need to check to see if there is a second one. If there is a second one, the second possible angle H would be 123.9. Would that be possible? Could I have an angle of 123 in the same triangle with an angle of 50? Yep. So this one has two possible triangles. All right, so I would guess there's going to be a section on your test tomorrow, your quiz quest tomorrow, that will not take all period, by the way, where you will have to tell me how many triangles are possible. So you could guess, because the answer is going to be 0, 1, or 2. I would prefer you actually worked it out so that you had a better chance of getting it right. All right, number 2, find the area of the triangle. All right, so this is a different problem, different kind of problem. All right, so think about what we talked about yesterday. I think it was yesterday. There are really 3 ideal situations when we talk about finding area. The 3 ideal situations right now, we're going to find other ways in our future, but right now, the 3 ideal, Patty, I am going to come unglued. The 3 ideal ways of finding, or ideal situations for us, would be to have an altitude that is a perpendicular. I don't have it. Another ideal is to have 2 sides and the included angle. Remember, 1/2 side, side, sine. We don't have it. And the third ideal situation is to have all 3 sides. Because if we have all 3 sides, we can find the area real handily using Hero's formula, which is simply the big radical with 4 numbers inside of it. Right? And what are those 4 numbers? Well, the first one, you got to find the first one first. That is the semi-perimeter, which is half the perimeter. So my perimeter is 30. So half of it would be 15. So I start with a 15 right here. We always start with our semi-perimeter right there. Now, what goes in the rest of these? Very simply, do not tell me the sides go in there. They don't. Don't put 8, 10, 12. That will be wrong. 15 minus each side. So 15 minus 12, 15 minus 8, 15 minus 10. That's what goes in there. So we start with our semi-perimeter, and then we take the semi-perimeter minus each side. Then we just multiply them all together and take the square root. I got 39.69. And if these were inches, that would be square inches, whatever the unit is. You're finding area, so it's going to be a square unit.
If there's no unit, we put unit squared.
Sure. All right, so now we got this one. Still finding area. Okay, remember our sides are labeled opposite our angles. Okay. All right, so let's back up again. What are the 3, if I'm going to find area, I either need an altitude, that is a perpendicular, I need all three sides, or I need two sides and the included angle. That's what I need to find area. If I don't have one of those things, then I need to do some work, like law of sines or something, to get it. But I have two sides and the included angle. So this is a no-brainer. Area is 1/2 side times side times sine of included angle. 1/2 side sine. SSS, 1/2 side sine. That's going to be the area of the triangle, and I'm just going to type it in. I don't have to do any work. I don't have to do anything tricky. The area is 95.07. We'll say centimeters this time. Okay, so what do I need for area again? I either need an altitude, so I can do 1/2 base times side. I need all three sides, so I can do Hero's formula. Or I need two sides and the included angle, so I can do 1/2 side sine. Those are the things, that's what I have to have if I'm going to find the area. Okay. Find the perimeter and area of a regular nonagon inscribed in a circle of a radius 12. So there's my circle. What do I mean by a regular nonagon? 9 sides, all congruent. So I'm going to try to spread out 9 dots around this circle. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to connect those. And there's my, use your imagination, regular nonagon. Okay, we did one of these yesterday. What do we do? What was our strategy?
Split it up.
We know the radius of the circle is 12, so we know that segment right there is 12, right? And in fact, we know all of these are 12. And we know all of these triangles, regardless of how my picture looks, all those triangles are congruent. So if I could find the area of one of them, then I just times by 9 and I have the area of the figure, right? Okay, so let's stop and think. What do we need to find the area? We either need a right angle, we need two sides and the included angle, or we need all three sides. I'm looking at my triangle right here. I'm looking at this guy right here. What do I have the easiest chance of getting? I could get any of those, by the way. But the easiest one is going to be which one, Patty?
Finding one angle.
Finding the central angle,
Yes.
right? The vertex
Divide
angle.
360 by 8. We tried
9.
9.
It's an octagon.
I
So
was thinking octagon.
360 divided by 9 is 40. So all of these little central angles all around here are 40, right? They make 360 and they're all equal. So what's the area of that triangle going to be? 1/2, so this is the triangle now. This is not the answer to the question. The triangle is 1/2 side times side times sine. So I can type that in, 1/2 side times sine. So that number right there is the area of this little triangle. If I want the area of the whole figure, I'll just take that number and times it by 9. So my area is 416.53. How will you speak this time? Now, yesterday, I don't remember, like it was a pentagon or an octagon or something, I don't remember. Doesn't matter. The strategy is exactly the same, right? No matter what kind of regular polygon we have. All right, number 4, we've got ourselves a parallelogram. It doesn't say that, and it should, because I was lazy. It's a parallelogram. So we've got this parallelogram here.
Were we supposed to find the perimeter on that last one?
Oh, wait. Oh, we were. Okay, let me just finish this drawing, and then we'll come over and we'll find the perimeter. Yes, because it says find perimeter and area. So we've got the area. All right, so yes, I need to find the perimeter. 2-part question, thank you. All right, so I've got the area figured out. I'm back to problem 3, doing the other part of it. I need to find the perimeter, which I guess means I really need this to know what that side is right there. Because if I knew what that was, I could again times it by 9, and that would be my perimeter. Okay, now this is not area. This is finding a side of the triangle. When you're finding a side of the triangle, you need either the law of sines or the law of cosines. So looking at what we currently have, we could use the law of cosines, and it would say what? X squared equals 12 squared plus 12 squared minus 2 times 12 times 12 times cosine 40. And those are the ones, when the variable's over here by itself, you can just type all that in. You don't have to do any messing around at all. You can just type it right in. The only caution I have is, don't forget when you get it all typed in, that's x squared. So you still need to square root it. I got 8.21. Is that right?
Yeah, I got that.
So what would my perimeter be? I'm just going to hit times 9. And the perimeter, this was the area, the perimeter is 25.79. And if these were feet, then that would just be the perimeter is 25.79 feet. Oh, no. Somehow I hit another button. Sorry about that. Yeah, that's not right. Somehow I did something and hit a button myself. Did you get 73.8? I have 8.
Yeah.
Okay, is that all right with everybody? Now, I do want to point something out here if you wanted to. In this kind of problem, these little triangles that you build will always be isosceles, right? They'll always be isosceles, the triangles. So that means these angles will always be congruent. So you will know that one already. I mean, you're going to figure that one out. So if that's 40, these would have to each be 70. Does that make sense to you? So if you wanted to use the law of sines to find this, it would be easy to do. If you didn't want to use the law of cosines, you could say sine 40 over x equals sine 70 over 12. You'll always be able to find those base angles if that's the way you let them do it. All right, so now I'm back to my parallelogram. And before I start cluttering up the picture with anything else, diagonals and whatever, I'm going to remind myself that they may have given me this angle, which of course matches this angle, but I know this one, because what's the relationship between these two? They're supplementary. So if that's 122, I'm just going to go ahead and label this one right now, 58? Now I may or may not need that, but I'm going to go ahead and label it anyway, just in case I need it later on. Okay, now, what am I supposed to be finding? AC, so I'm gonna find the longer diagonal. Does that diagonal bisect the angles? No, only in a rhombus. Okay? You don't know anything about these angles right now except they add up to 58. Alright, I want to find the length of that. Take a look at what you've got here. I'm looking at this triangle right here.
Side angle side.
I have side angle side, so if I want to find another side, I'm going to have to use the law of cosines. So it's going to say x squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times cosine 122. Remember, you know nothing about any of the other angles in the problem. So you do not have a pair of information, so you've got to use your law of cosines. Yep.
Did that include an angle formula?
If I wanted area, the question says find AC. Now, the next question says find area.
Oh,
That's an area formula. 6 squared plus 14 squared minus 2 times 6 times 14 times cosine. Okay, so don't forget to take the square root. I got 17.92. That's the length of the diagonal. Remember, if you're finding a length or an angle, you're using the law of sines or cosines. The next question says, find the area of that guy. Well, in the given, we had 6, 14, and 122, right? So the best way of finding the area is to use which of our little formulas? 1/2 side times sine of included angles. Is that the answer? You gotta multiply it by 2. Or, if you're clever, just forget that, because you're gonna be doubling it anyway. It's up to you. You should get 71.24 as the area of the parallelogram. Alright, and then number 5 says, we got a triangle. M is 16, N is 18, and R is 20. And I need to find the measure of the largest angle. Okay, so I'm going to figure out which one is the largest angle first of all. R. And I know it's the largest angle because it's across from the largest side. So I need to find angle R. And I just got done saying that if you're looking for a length or an angle, you're going to use the law of sines or cosines. So you just need to look at the situation and decide. It's going to have to be cosines. Why?
No angle.
There's no angle to make a set. You don't have a set of anything. So, law of cosines, if I'm going to find angle R, then over here, remember in the law of cosines, you got one thing over here and then all the rest of it. What's the thing that's going to be over here all by itself if you're finding angle R? 20 squared equals 18 squared plus 16 squared minus 218/16 cosine R. Alright, go ahead and type that in. These are the ones you have to be a little careful. They're not hard, you just need to be a little careful. What you come up with is the measure of angle R. I didn't get 90. Yeah, I got 71.79. So, those of you that didn't get that, let's try that again. So, we're going to have 20 squared, right? And you're going to add these two together and subtract them over. And then you're going to subtract those over. Then you're going to multiply all that together and divide it over. Then you're going to second cosine. So do we get 71.79 this time?
Are you supposed to second cosine?
Mm-hmm. Anytime you're finding an angle, you're going to have to do that. Okay, if you're not, we're going to move on. If you're not getting 71.79, write down every single step. Just write down every single step. It's not that, it's not hard. Just write down every step and you can do it. All right, last question says find Q, side Q. Okay, so if I'm finding a length, a side, or an angle, I need my law of sines or cosines. So which will it be here? This will be the law of sines because I know two of the angles, so I can find the third. And once I know that guy, I have my match set. So sine 51 is to 19, as sine 48 is to q. Is this going to be a problem where I have to worry about a second answer? No, that's only when I'm finding an angle, right? Only when the variable's up here. So this is just a straightforward problem. So it should not be a problem to find side Q. .61. Oh, that seems awfully low. Let me try that again. Oh, it's 19. That's not right. I hit 9. 18.17. Is that better? 18.17. Okay. All right, so Prequest number 2 is done. All right, would you look on the back of, let's see, on the back of the second sheet is a little review number 3 sheet. Some of these refer to book problems. So is there anything on review number 3 that we need to look at? And some of those are book problems. I didn't recopy them out of the book. So you might want to get your book out and look and see if there's anything there that because it's a different book. Let me see what those are. Let's try a couple of these. Yeah. All right, so let's find one of these problems from the other book. One of them is one of these deals, where you have to find the area of this odd shape. Actually, that isn't the question. The question is, all right, so there's the figure, and then it says fencing is $250 a foot. Find the cost to fence that area. Okay, so it says fencing is $250 a foot. Find the cost to fence in that area. Okay, so what's your thought on that? What are we gonna do? Split it up. How do you wanna split it up?
Make it a rectangle or triangle.
Bottom left, top right?
No, that's not what I said. No.
That looks like a triangle.
Top left to bottom right.
How about if I just do that? Now, why would that be beneficial? Well, how long is that segment I just dropped down? 30. So I know that this whole angle is 128.
Minus 9.
So this is 90, which means this guy must be 38. Now, I know this is 50. This part right here is 50. I really just need to know, I'll call it X and Y. I need to know those two pieces. Would you agree with that? So, do I have the ability to find those two pieces? How? Well, got a couple of options. One, if that's 38, then I know this has to be 52. So could I do my law of sines? Absolutely. I heard somebody else say, let's just use tangent. Is it true that tangent 38 equals x over 30? So that would be another option. Remember, if you have a right triangle, you're allowed to use SOHCAHTOA. Or you can go ahead and use the law of sines and say sine 52 over 30 equals sine 38 over x. Those are going to come out to be the same answer. It doesn't matter how you do it. And then, could we do something similar to find side y? The Pythagorean theorem is okay, but remember that's rounded off. So it's probably better if you have another option to use another option. I think we do have other options. We could go back to the original idea and say cosine 38 equals 30 over y. Cosine 38 equals 30 over y. Or, using the law of sines, sine 52 over 30 equals sine 90 over y. Either one of those would give me the missing sides. All right, and then what am I going to do? Remember, the original question was find the cost of enclosing the field, enclosing that area. So what would you do then? Once you figured out what x and y are using one of these strategies, add them all up, add up all these, so 50 and 30 and 50 and your x and your y, add them all up and multiply by 2.5. And that would tell you how much it would cost to close in that area. Okay?
For y, I got like 30.07. I don't know if it's right.
That seems kind of small.
I did. So you're supposed to find like the y over for cosine. I did cosine 38, I can also put y over, and then I divided cosine 38 by 30. Or 30 over cosine 38.
Yeah, when I did 30 divided by cosine 38, I got 38.07. Okay, all right. Let's see, is there anything else on that paper? And the rest of those problems are anything different, so. A regular pentagon, we know how to do that. Let's look at 2D. Problem 2D. All right, let's look at 2A or 2B, I mean, 2B. How are you going to do problem 2B? Hero's formula, absolutely. How are you going to do problem 2C? People, how are we going to do it? 1/2 side sine, right? So B is heroes, C is 1/2 side sine. What about D? This is a different situation. What? I need to find another side. There's a box right in here. I need to find another side, because in order to find the area, I need 2 sides and the included angle. So it doesn't matter which side I find. If I found this side, then I would have 1/2 this sine 42. If I found this side, I'd have 1/2 5 this sine 58. It doesn't matter, but you need another side. Does everybody see that? So we're not going to be able to get the area right off the bat. We're going to have to find another side. So let's just say we want that one. I'm just saying, let's just find that one. So I first of all figure out what angle B is. Angle B would be 80. Now how am I going to find side A? Law of sines. So sine 80 over 5 equals sine 42 over A. Now I'm not going to get too excited when I find side A, because that is not the answer to the question. I got about 3.4, did you? I may take a few more decimal places than that since it's not the answer. 3.3, 3.39726.5. Is that what you got for side A? Now how do I find the area? Now I go back, and right here is my combination. Right here are my 2 sides and my included angle. So the area is going to be 1/2 5 times A times sine 58. So I have A right, oh shoot, I have A right here. So 1/2 times 5. Oh, 58. What'd you get for your area? 7.2 about. So what's the moral of that story? If you don't have what you need to find the area, then you need to find what you need using the law of sines or cosines. Okay, any other questions you want to ask me? In preparation for tomorrow's quest. Wyatt? Go over which one? Find the area. This is an isosceles trapezoid. We did one like this yesterday, I think, maybe not. Want to find the area of a trapezoid. Now there is a formula for it, so if you happen to remember the formula, you can use it. But we don't have everything we need for the formula. My personal preference to finding the area of this thing is to drop a couple of perpendiculars. Since it is an isosceles trapezoid, I know that these two pieces are each going to be 3 because this one is 10. And this is a right triangle, and I know 2 of the sides. So I can do the Pythagorean theorem to find this one. So 9 plus h squared equals 64. So h squared is 55. I got root 55, if I did my arithmetic right. So now I actually have what I need if I want to use the trapezoid formula, or I can find the area of the little triangles, there are 2 of them, and then the area of the rectangle, and add them up. So this is a right triangle, that is a 90-degree angle, it's a height, it's an altitude. So the area of the triangle would be 1/2 the base times the height. So that would be the area of this triangle, 1/2 the base times the height. That one, of course, is going to match exactly. And the rectangle has an area of 10 times root 55. Base 10, height root 55. So if I just wanted to add all those up, 13 root 55 would be the exact answer. You could also get a decimal cat if you didn't say answer exactly. But that would be one strategy. Now there is a formula, like I said, if you happen to remember, the area of a trapezoid is 1/2 the height times b1 plus b2. So once you found the height, your bases would add up to 26. So that's a little quicker way of getting 13 root 55. Anybody else think of something concerning the quest you're going to take tomorrow that will not take all period? Because it's only 1 page front and back. Do you have to have a calculator tomorrow?
Yes.
Yes. You absolutely have to have a calculator tomorrow, so make sure you have one. Okay? Alright. Go ahead and homework and review work, everything's due tomorrow. It's only 4 things total. So use this time, got a few minutes left.